This PowerPoint presentation accompanies Lesson 4. All right, Tutor 1, you're going to have to open Tutor 1, and if you go to the Teams course page under Files, you'll see there's a folder that says Chapter 4 Parts. If your Tutor 1 wasn't made to the right specifications and measurements, then you can download a Tutor 1 that is made correctly to use for this lesson. Features used to build Tutor 2. So you'll be creating a back to this camera front and call it Tutor 2. All right, you're going to use a base extrude, so it's going to be a block. And then you're going to use fillets to curve the edges. Then you're going to shell this. And then you're going to cut extrude to have this lip so that the camera can fit right on the top of this. Sketch for cut feature. Sketch is composed of two curves. Convert entities creates the outside curve. Offset entities creates the inside curve. Rather than drawing the outlines by hand, they are copied from existing geometry. This technique is fast and easy. Select the face and click the tool. Accurate, sketch entities are cloned directly from existing geometries. Intelligent, if the solid body changes shape, the sketch updates automatically. This is the Convert Entities button on our toolbar. Copies one or more curves into the active sketch by projecting them onto the sketch plane. Curves can be edges of faces, entities, and other sketches. Easy and fast. Select the face or curve, click on the Convert Entities tool. It looks like this. Create the outside curve. Sketch or select the sketch plane. So you select this face right here, the plane face. Open a new sketch. Convert the face or curves you want to convert. In this case, select the face. Click Sketch and then the Convert Entities button, creating the outside curve. Outside edges of face are copied into active sketch. Sketch is fully defined, no dimensions needed. So we've created this outside line. To create the inside curve, click Sketch, Offset Entities, and the Property Manager opens. This is the Offset Entities Property Manager. You'll set the dimensions and then you'll either reverse it for inside or outside. Another distance value of 2 millimeters. Select one of the converted entities. The select chain option causes offset to go all the way around the contour, creating the inside curve. The system generates a preview of the resulting offset. So it shows you this is the offset. A small arrow points toward the cursor. If you move your cursor to the other side of the line, the arrow changes directions. This indicates on which side of the offset will be created. Move the cursor so that it is inside the contour. Click the left mouse button to create the offset. The resulting sketch is fully defined. There is only one dimension. It controls the offset distance. Tutor assembly. The Tutor assembly is comprised of two parts. Now that we created Tutor 2, we're going to create an assembly using Tutor 1 and Tutor 2. Tutor 1 was created in Lesson 2. Once again, I've placed this Tutor 1 with the correct dimensions in the file folder in Microsoft Office 365 Teams in the Lesson 4 Parts folder. Tutor 2 will be created in this lesson. An assembly contains two or more parts. In an assembly, parts are referred to as components. Mates are relationships that align and fit components together in an assembly. Components and their assembly are directly related through file linking. Changes in the components affect the assembly. Changes in the assembly affect the components. Here we have two parts. Open the new assembly document template. Open Tutor 1. Open Tutor 2. Tutor 1, Tutor 2. Arrange the windows in such a nice way. Drag and drop the part icons into the assembly document. Save the assembly as Tutor. Drag and drop, drag and drop. Drag and drop, drag and drop. The first component placed into an assembly is fixed. That means you can't move it around. A fixed component cannot move. If you want to move a fixed component, you must float unfix it first. Tutor 1 is added to the Feature Manager design tree with the symbol F. F means fixed. Symbol F indicates a fixed component. Tutor 2 is added to the Feature Manager design tree with the symbol negative or slash. Symbol negative indicates underdefined component. Tutor 2 is free to move and rotate. Move components by dragging. Move components with a triad. Move component moves the selected component according to its available degrees of freedom. Rotate components by dragging. Rotate components with a triad. Rotate components rotates the selected component according to its available degrees of freedom. Rotate. Degrees of freedom, there are 6. They describe how an object is free to move. Here's our triad. Translation is movement along the X or Y and Z axes. Translate up, translate down, translate out across to the X, back and forth, translate in or out on the Z. Rotation around X, Y, and Z. Rotate, rotate, rotate. Mate relations. Mate relations align and fit together components in an assembly. The Tutor assembly requires 3 mates to fully define it. The 3 mates are coincident between the top edge of Tutor 1 and the edge of the lip of Tutor 2. So if you click on your mate and then click on this face and then the inside face, it'll align so that they are in the same plane across. That's coincident. Second mate, coincident mate between the right face of Tutor 1 and the right face of Tutor 2. All right? So if I click on this face and I click on this face and or top ones and I hit the coincident, they'll be in the same plane along this plane and they'll be the same plane along this plane. Third mate is coincident mate between the top face of Tutor 1 and the top face of Tutor 2. So we had them first, they were lined up in this plane coincident, and then we had them lined up in this plane coincident, and then we have them lined up in this plane coincident. When you have them lined coincident in all 3 planes, they match up perfectly. The first mate removes all but 2 degrees of freedom. So you've put it in this plane, you could still rotate it. You could still move it back and forth. You could still move it back and forth, and you could still rotate it. The remaining degrees of freedom are movement along the edge and rotation around the edge. The second mate removes 1 more degree of freedom. The remaining degree of freedom is rotation around the edge. So when you add this mate, you no longer move it back and forth because it's coincided with this one. The third mate removes the last degree of freedom. No remaining degrees of freedom. The assembly is fully defined. Doesn't that look nice? The switch plate requires 2 fasteners. Create the fastener. Create the switch plate fastener assembly. So once again, the switch plate we created in an earlier lesson, and I've placed a switch plate that was made correctly with the correct dimensions in the parts folder for lesson 4 in Microsoft Office 365 Teams. You'll have to make your own fasteners or screws according to the directions in the packet and the video directions. The switch plate fastener assembly requires 3 mates to be fully defined. The 3 mates are The first mate is a concentric mate. The outside of this circle is concentric or has the same center as the inside of this circle between the cylindrical face of the fastener and the cylindrical face of the switch plate. The second mate, the coincident mate between the flat circular back of the fastener and the flat front face of the switch plate. So we have a coincident mate. You click on the face of the switch plate and you click on the inside face of the fastener, and that will create these two to lock together. Third mate is a parallel mate between the flat cut face of the fastener and the flat top face of the switch plate. The switch plate fastener assembly is fully defined. You want this inside line to be parallel or fully horizontal to this face on the top so that it's screwed in correctly. The CDK storage box assembly requires three mates to be fully defined. The three mates are: first, concentric between the inside bottom face of the storage box and the bottom face of the CD. So we have the bottom face of the CD is concentric with the inside face of the storage box. The storage box with the correct dimensions and the CD case with the correct dimensions can both be found in Office 365 Lesson 4 parts in Teams. The second mate, coincident mate between the inside back of the face in the storage box and the back of the CD case. So the back of this face here is coincident mated with the back face, the inside back face of the storage box. The third mate is the distance mate between the inside left face of the storage box and the left face of the CD case. So you have a distance of 1 centimeter. You have this face will be mated to where the dash line, the other face, the face closest to that. And then you want to add a distance of 1 centimeter. Good job. Now you would like to do that 24 more times so you can get 24 CDs in here. Not. You would like to do that. Not. All right, so you can make a component pattern. It's a pattern of components in assembly. The component pattern copies the seed component. So we're going to use the one CD case as a seed component, and then we're going to copy it. This eliminates the work of adding and mating each CD case individually. Select the CD case as a components to pattern. So we have a linear pattern. We have the CD case as the components to pattern, and then we want click on the assembly linear component pattern, which we did. Select the front edge of the storage box for pattern direction. Spacing 1 centimeter, instance of 25. So we have the edge, we're selected for the direction, and then we have 1 centimeter apart, and we want 25 of them, and then click OK. More to explore, the hole wizard. What determines the size of a hole? The hole wizard does. The size of the fastener, the desired amount of clearance, normal, close, or loose. We'll be using a hole wizard in later lessons, but if you want to try to create holes for no apparent reason, go ahead and do it.